So this is the review, Unit 9 review. This is video 2. So we're on the second page here where we are graphing and doing transformation rules. So we need to know our transformations. Remember, we identify A, H, and K to help us. Okay, so A, let me put the function. So that's for cubic. That's for cube root. But you can see A is what's multiplied in front on the outside, H is what's subtracted on the inside, and K is what's added on the outside. Okay, so when we identify A, H, and K here in number 2, A is an understood 1, H is 5, and K is 4. Now you need to recall, do my highlighting here. Nothing there. I guess I shouldn't highlight the parenthesis. That might confuse you. And then your K. All right. So we need to recall what A, H, and K do to the graph. Knowing what they are is great, but if you don't know what they do, what are you going to do with it? So A is what stretches or compresses our graph vertically. And when A is negative, that's what reflects our graph. So in the parent function, A is an understood 1. So that means if A is 1, just like in the parent function, there's no change. So A in this graph is not affecting the graph in this function. Okay, but your H and K in the parent function are 0, 0, because there's nothing added inside or subtracted, and there's nothing added or subtracted outside. So normally that's 0, 0. That's that starting point of inflection. But here we have H and K, not 0. So they're both affecting our graph. Remember, H is the horizontal shift. So this is going to shift right 5 because H is positive. Remember, it's the opposite sign in the equation. So it's minus 5 in the equation, which means H is actually positive 5, so it's going right 5. K is straightforward, it's positive, so up 4, because K is your vertical shift, up or down. So that means normally your HK, your point of inflection, is normally 0, 0 for the parent function. Okay, but here my HK is 5, 4. So that is my point of inflection. That's where I'm going to start my graph. Now, I know in the parent function for a cubic, I go over 1, up 1, left 1, down 1, from the point of inflection. Go over 2, up 8, that would be off this graph, or left 2, down 8. And then I connect those points and I have that nice, pretty curve like this. Now, if you are not familiar enough with your parent function to know the movements that they should be from the point of inflection, because remember, there was no stretch or compression or reflection, so they should just be the same movements as the parent function. It's okay. Use Desmos. Go just type this equation into Desmos and you can see what it should look like. And you can see what click on the graph and see what the points should be. Or make yourself a table and it'll list the points. Okay. Now, domain and range. I harped on this and harped on this and harped on this last week when we were going over graphs. This domain and range of cube and cube root never change. It does not matter if there's a reflection, a stretch, a compression, a shift up, down, left, right. This graph of a cube or a cube root will go on forever in all directions. It's going up and to the right here and down and to the left. Okay, but that could be flipped around. It doesn't matter. It's going forever. So it is all real numbers. or negative infinity to positive infinity in interval notation for both domain and range, no matter the transformation. So please do not miss a domain and range question. All right, let's go ahead and fill it in. Domain and range for all of these. Look, this is cube root, cube root, cube root, another cubic, another cubic. I will tell you the domain and range for every single one of these. You can use the all real number symbol like this, or the interval notation like this. For the sake of writing, I'm just going to put the all real number symbol because it's faster. I know the domain and range for every single one of these without even looking at the graph or what the transformations are. All right, so we got 2 more cubic to do here. Okay, so what we are doing is identify A, H, and K, and then state what that transformation is. So A here is negative. So that is going to reflect over the x-axis. Your H in the equation, it says +3. So that means your H is -3, because remember, it's the opposite for H. So that's going to be a left 3 shift. And your K is also negative here. So that's going to be a down 3 shift. So HK, both -3. So I'm going to start at -3, -3. Now, normally in the cube, we said we go right and up or left and down. Okay, the parent function is this shape. However, because this negative is here, it's reflected, so it's going to be this shape. So we've got to reverse. So now the numbers, the distance that you're moving left and right and up and down are not changing because it's not stretched or compressed. It's still a 1, but it's just going the opposite direction. So instead of up and to the right, or excuse me, yeah, right and up, I'm going to go right and down. 1, 1 or 2, 8. But the 8 would put me, it would just put me just barely off. I'll put it. Okay, and left and up. 1, 1 and 2, 8. And then you can sketch that curve through those points. So you can see that curve has been shifted left 3, down 3, and reflected. So it's got the opposite direction. This one was not reflected, so it went this way. It's increasing left to right. This one is now decreasing left to right. All right, in 4, A is an understood 1 again, so no flip, no stretch, no compression. H is -2. And K is +3. So that is left 2, up 3. So my point of inflection is at -2, 3. And there's no stretch, compression, or reflection. So I'm just doing the normal movement from the parent function. So right and up 1, right 2, up 8. It's going to be just off. Left 1, down 1, and left 2, down 8. And there's that function. And again, you can get all of these graphs in Desmos if you're not comfortable graphing by hand. All right, now we're getting into cube root. AA and KH still affect the graph in the same way, no matter what type of function it is. So A is the coefficient out front. So in this case, -1. So that is again going to be, make the graph reflect over. All right, give me 1 sec. Just happened.